So one of the important things you must know is how to define statistics. So the keyword is this was the collecting, analyzing, and interpreting, presenting, and organizing data. Then yeah, because they can ask you to give their primary purposes, so you must know how to define. So I've got two branches of statistics: descriptive and inferential. So this one, the descriptive, it summarizes and describes the features of the dataset. This one, it makes predictions. The inferential. Then we come to, so the things I'm skipping, they are not gonna ask in most cases. What is the difference? Okay, they can ask the difference between probability and statistics. So statistics is the study of collecting, analyzing data, as I've explained. Then probability knows the likelihood of an event happening. Then there is also this one. Population is any entire collection of people, what. And then a sample is a subset of a part of a population. And then I was still explaining. Okay, yeah. So I was saying a sampling. When they say sampling is a subset of a population, generally taken for the purpose of statistical inference. Then simple data is a set of measurements of samples, elements. And then parameter is a value that is used to represent a certain characteristics of a population. Then we must know the difference between an estimator and a pivot quantity. So an estimator is statistics that is used to estimate the unknown. Then the and then of a parameter, theta, or a function. T theta is called an estimator of theta or T theta. Later on, you'll see you'll be calculating the expected estimate. And they say estimate. The observed numerical value is the value that you found denoted by t of x is the estimate, such as maybe the expected of x is an estimate. Okay, then we've got pivot quantity is a function of only x1 up to xn, and theta whose distribution does not depend on theta. Then you must know how to define a census. Is an official count of the entire population, and then simply a certain randomly selected fraction. So you must know the advantages and the disadvantages of this of census and sampling. They are likely going to ask, and also the reasons why we are going to be performing say census and instead of performing sampling. So in terms of what, of course, sampling will require fewer resources. So these are the advantages of sampling. Sampling requires fewer resources than surveying an entire population. And then in a census, collecting data from a subset takes significantly less time rather than conducting a full census, right? So you must be able to break this down. So let me see if there is something. Okay, I think this is the end of the slide. So the disadvantages of sampling compared to sensors. So we know that in terms of the sampling error, the result from the sample are the estimations and may not perfectly mirror out the whole entire population. So you must be able to explain the disadvantages in terms of biasness, sampling error, and the precision of subgroups. So you will also check how you can explain this in a more. And another reason is that sampling is performing sampling is more expensive. So you must be able to mention those points. Then let me go to another slide quickly. So this is chapter 3. I'll just give a summary, right? So you know the mean is given by that and the variance is given by that. Okay, and then we have got the methods of point estimation of the maximum likelihood, the method of moments estimations, the method of least square estimations. So basically we have the MLE, MME, MLS. So you must not calculate each one of them. Then this one is for calculating the likelihood function, and then it's going to be denoted by this. The likelihood of a function is the natural log of the likelihood function. So the function is ln the log of that function, and then the MLE is the derivative with respect to theta, and then you equate to 0. So basically you are going to differentiate this. You are going to differentiate your likelihood function to get your maximum, to get your what method of least square estimation. No, to get your MLE, which is your maximum likelihood. Yeah, you differentiate to get MLE with respect to theta. So meaning you're going to differentiate both sides here. So most of the things here, well, having questions. Here you have a Poisson distribution. They say find the maximum likelihood. So it means that you're going to perform some derivatives, right? So most of the stuff is, yeah. So you're going to say just that I cannot write here, but let me try. You're going to introduce the product here. Let's change the color to. You're going to introduce the product. Then from I equal to 1 up to n, then you'll introduce ln both sides. And also this side you'll introduce ln, and then you solve. So at the end of the day, you should get lambda is equal to x bar. And they say calculate the estimate using this estimation when x is 1. So we'll do such things, but you're going to just add 1, 2, 4, and 2. You divide by 4. Remember that it is equal to x bar. And then we have got this part. This is the method of moments, né? So you must be able to perform this So they say let x equal to the normal distribution of that. What are the estimator of the population mean and variance? If we use the methods of moments, we know that mean is equal to x bar, variance is equal to 1 over n, the sum of xi minus x bar all squared. So, and the first moment is it's equal to mu. Then the second moment is the expected of x squared. So we will check how you can calculate this part because there is a lot of computation we're gonna have to do, but not something hard. Find the least square estimator. Then to find the biasness, you must use the formula E of theta minus theta. The definition, you must know the definition of what is bias. It's this one. The statistics is unbiased if the expected of x is equal to x for all x. Then this is another definition that you can write. Then this is an example, another one here. So we'll do these examples, another one here. The standard error, this is the definition of the standard error. We know is the square root of the variance. Then the mean square error is given by this. Okay. Yeah, so I'm going to stop the recording here because this is more of calculations. So as long as you can know also this part, this is another part, the properties of a point estimators. You must know how to calculate the unbiasedness, the efficiency, relative efficiency, sufficiency, and consistency. And also, so for efficiency, it's just the MSE, the mean square estimator of 2 over 1. So we must also know the conditions which we'll discuss. So I'm going to stop here for now.